So yesterday we were discussing about the relation and functions.
Yes.
Okay. So any doubt in the last topic, which we have done yesterday? Right. We have completed the Cartesian product. Then we have started the relation. Okay. Then we have done the domain. I'm not sure. We have done the domain of a function. No.
No
Asif? No.
domain.
Okay. Then we have done the relation only. Then this domain topic is also of class 11th. Okay, then what is a domain? Let R be a relation from a set A to set B, then the set of all the first component. Okay, or we can say the coordinates of the ordered pair belonging to R is called the domain of the function. So suppose we have this relation. 1, 2, 2, 3, 3, 4. Okay, then the set of first component, that is 1, 2, and 3. The set of first element, this is called the domain of the relation. Okay, so domain is what? First component, 1, 2, 3. So this is called the domain of the relation. First, we have just started this. No issue first. So we have just started the domain of a function. So domain is what? If you have a relation, then the set of the first component. So we will take the first value, which is called the domain of the function. This clear? Fahad and Asif, this clear?
Yes.
Okay.
Yes, sir.
Okay, very good. Then yes, I can repeat. So for yesterday we have started the relation, and this topic is also of class 11, domain of a relation. Okay. So what is a domain? If you have a relation, then the set of first component, like 1, 2, 3. Okay, then the set of first component is called the domain of the relation. Okay, Fahad? Okay. So there's one more example in the slide. For example, okay, so in set builder form, how we will write domain? Domain is A. What is A? A is present in the ordered pair which belongs to R. So if you have an ordered pair which belongs to the relation R, then the first component is called the domain of R. For example, if you have these two sets A and B, okay, and you have this relation, then what is the domain in this case? Anyone can tell me in this relation? Asif, Fahad, can you tell me what is the domain in this relation? Yes, 1, 3, 5. Okay, instead we never repeat a term. So the domain is 1, first component 3 and 5, and 1 is already there. So we will write the domain is 1, 3, and 5. Okay, so domain is 1, 3, 5. So I hope this is clear to you. So please note down this and then raise your hand once it is done. Then we will start the next topic. Okay. Okay, Asif, very good. Fahad, this is done. Fahad, this is done. Shall we start next? Please confirm me once it is done so that we can start the next topic. Okay, Fahad, very good. Next one. Next is a range of a relation. Okay, so what is the domain? The first component. What is the range? Second component. Okay, the set of second component of the relation R is called the range of the function. So what is the range? Let R be the relation from set A to B. Okay, you get used to from this term. Okay, from that let R be a relation from set A to set B. So we have a two set A and B. Then the set of all second component or coordinates. So the ordered pair belonging to R is called the range of R. Okay, so what is the range of R? The set of second component. So how we can represent this? We can represent like this. Range of R is equal to B. What is a B? We have the ordered pair which belongs to the relation R. For example, in this one. So anyone can tell me what is the range?
So range is the second component of a pair.
Yes. So in this example, what is the range? Good for this is
So
correct.
8624.
Very good answer. This is correct. Okay. So range is 8624. So please note down this, then confirm me, then we will check the next topic. Everyone, oh, okay, for Asif, please raise your hand once it is done.
Yes, sir. Just a second.
Okay. Okay, and then we will start next. Next is what? Next is a relation on a set. Okay, what is mean by relation on a set? In the previous cases, we have checked that we have two sets, A and B, and then we have find it the relation. We have a set A and set B. And from set A to set B, we have find a Cartesian product, and from that Cartesian product, we have find out a relation. But what is meant by relation on a set? This we have discussed yesterday also, that let A be a non-void set. You know that what is a non-void set? Then a relation from A to itself, that is a subset of A cross A, is called the relation on a set A. So what is mean by relation on a set A? Here you will first of all find the Cartesian product of A cross A. That is Cartesian product between the same set. After finding the Cartesian product, then you will find the what? Then you will find the relation. So relation on a set means you are finding a relation on a single set only. In place of B, you will use same set A. So this point we have already discussed, because the questions which we have done yesterday, in that you have a single set only. Okay, so whenever it is this statement is given relation on a set, then that means you are finding the relation on a single set. Okay. Okay, so please note down first definition relation on a set, then confirm me, then we will start the next one, inverse of a relation. I hope you have completed this. So we will start the next one. Next is inverse of a relation. What is meant by inverse? Let A and B be two sets and R be. Can you give an example of relation on a set? Yes. For example, if we have this one, A is equal to 1, 2, 3. Okay. And we find a Cartesian product, A cross A. We get what? 1 comma 1 because the second set is also A. 1 comma 1, 1 comma 2, 1 comma 3, 2 comma 1, 2 comma 2, 2 comma 3, then 3 comma 1, 3 comma 2, 3 comma 3. Okay. Now we need to find the relation, and if I will give you the condition that the both numbers should be even, then we will select this one, 2 comma 2. So here we have formed a relation from a single set only. Okay, we have find out the Cartesian product A cross A, and from that we have selected a relation. So this is called relation on a set. This is clear. First, this clear. We can get any condition, but the thing is we do not have the second set B. In place of B, we will use the same set. If you will check our previous relation, okay, then even in this case we have two set A and B. But what happened in relation on a set? Here we have a single set. So we do not have the second set B. We have only a single set A, and from A only we will find the relation. So we will find the Cartesian product between A and A. This clear first? Okay, very good. Now next is the inverse of a relation. So what is mean by inverse? From the name only you can understood that inverse of a relation means just opposite of the relation. So for example, here A and B be two sets and let R be a relation from a set A to set B. Then the inverse of R is denoted by R inverse. This is a standard statement. Okay, first till here we have a standard statement. What they are saying that inverse of R is denoted by R inverse. This is the sign of inverse, and it is a relation from B to A. So if your relation is from A to B, then its inverse will have a relation from B to A. So it is just opposite of R. Inverse of a relation means opposite of R. So if R is a relation from A to B, the inverse of a relation means from B to A. And it is defined as like this. So if you have a R, for example, if you have a R like this, R is A comma B, then what is inverse? Inverse will become B comma A. So we can represent like this that R inverse is what? B comma A. And what is this? B comma A and A comma B. So here we have given that A comma B belongs to R. So what is A comma B? This belongs to the relation R. So what this R inverse will become? This become the opposite of A comma B. So here we will get B comma A. Okay, so inverse of a relation is nothing, it's just the opposite of R. This is clear, Asif and Fahd?
Yes, sir.
Okay, okay, Fahd, good. Okay, for example, if we have this relation, for example, you have this set A, you have another set B, you find out this relation 1A, 1AC, 2D, and 2C. Okay, be a relation from A to B, then R inverse is equal to, so I guess there is some mistake. This is what? This is 1. Okay, 1C. So R inverse will become what? R inverse will be opposite of this. So 1A is here. We will write the opposite of this, which will become A1. 1C is here. Write the opposite of this, C1. 2D is here, opposite of this, D2. C2 is here, opposite of this, C2. Okay. So if we have this relation, then inverse of this will become like this one. Okay. Please raise your hand if this is clear. Okay, fine. Good. Asif, this clear?
Yes, sir.
Okay, very good. And please note down this, confirm me. Then we will start the next topic. Okay, Asif, good. Fahad, this is done. Shall we start next? Okay, very good. Okay, Zad and Mariam, you have joined. So, Zad and Mariam, we will just wait for other students. So, as soon as they will join, we will start our last topic. Okay,
Okay.
and we will wait for 5 minutes. Then we will start it. And Mariam, I guess you have missed some topics. So please, in the next class also, in the next class, join 30 minutes earlier.
Okay, sir.
Okay. Okay. We have done the inverse of a relation. Then we have a types of relation. Okay. Yesterday we have done the 3 types, but there are 2 more types which we will discuss today. First is void or empty relation. Now we will take example. For example, if we have A is equal to 1 to 3. Okay. And I will give you a relation R is equal to A comma B. Okay. And the condition is A minus B should be equal to 10. Okay. And I will give you this condition that A comma B will belongs to A. So you need to select the value from set A only. Okay. And the value should satisfy this condition that A minus B is equal to 10. Okay. So Fahad and Asif, can you give me any example which satisfy this? Or there is no such example?
So 15 minus 5.
No, but we need to select the value from here, 1 to 3.
Yes, sir, then it's not possible.
It is not possible. Okay, Fahad. So we can't find any value in set A, so that when we will subtract them, we will get a 10. So this is not possible. So what you will get R, you will get nothing. You will get a null set. Okay, so such type of relation is called the empty or void relation, which can't be possible. Okay, so this is the standard definition. Let A be a set, then the relation on a set A is called void or empty relation if no element of A is related to any element of A. If there is no element in set A which is related to any element of A which satisfy the given relation. So such type of relations are called the empty or void relation, which can't be possible. Okay, so I hope this is clear to you. And just we will take this example. Consider the relation R on the set this defined by, again same, A minus B is equal to 12, which is not possible. That's why this is not a that's why this is called a void or empty relation. So R is an empty set. So we will say that R is a void relation in A. Okay. If it is possible, then what will become? Okay. So that depends. For her, we have a different types of relation. Okay. We, depending on the outcomes, we can say that is a reflexive, symmetric, transitive, and we have a one more that is a universal set. Okay, so if we will get any value, then depends what the value we are getting, we will decide that this is what. For example, yesterday we have done 3 types of relation. So if your value satisfy the reflexive, then we will say that this is reflexive. Okay. Okay, so please note down this and raise your hand, Asif and Fahad, then we will continue our last topic. But from the next class, please join 30 minutes earlier so that we can complete the topics which are left. Okay. Please let me know. Zed, is there any doubt?
So finished.
Oh, okay, sir. Okay. Okay. So Asif and Fahd, please confirm.
Writing, sir.
Shall we start next, Atif? Okay, Asif.
Yes.
Okay, Fahd, this is done. Shall we start next? Fahd, shall we start next? Okay, good. Okay, so we will continue our last topic. We have done all the types of relation, and yesterday we have started some questions. So again, we will continue those questions. Ananya, you have just joined, but from the next class, Ananya, please join 30 minutes earlier. Okay, because we need to complete the topics which you have missed. Okay. Okay, so we have discussed that what is the equivalence relation, and then we have tried some questions. Okay, we have done these questions. Okay, let me start from here. Now, the biggest challenge, as I already told you, the biggest challenge which you will face is how to represent your answer. Okay, so please check here again. First one. But the first thing, always remember, if you know that this is not true, this is false, then just give a simple example. Okay, if you know that the given relation is false, false for reflexive, symmetric, and transitive, then just give a simple example for which that relation is not true. But if we need to prove that the given relation is true, then we will explain it. Okay, as we have done yesterday. Now, please check the first part. First is what? The question is check the following relation R and S. We have a two relation. Okay, so the S is for the second part. We will analyze the first only for reflexivity, symmetry, and transitivity. Okay, so we need to check for reflexive, symmetric, and transitive. So the first part, check for reflexive. Okay. Now, what is the relation? A is related to B if B is divisible by A, AB belongs to N. So please remember in the reflexive, the first step is you need to assume the value from the set which is given. Okay, please check here how we will represent our answer. So in reflexive, the first step is always assume the value from the set which is given. So Ananya, can you tell me in the first part, what is the set which is given?
It is a set of natural numbers.
Set of natural number. Very good. Okay, so we will assume a single value. Let A belongs to natural number. Okay. Now, before we will proceed to the next step, you should know that what result you need. Okay, we will represent our answer, but before that, you should know that what we need. What we need here, the relation is what? A or B. What is the reflexive? Who can tell me? Asif. Asif, what is the reflexive relation?
Sir, a relation in which both the like a relation in which the first and the last
Mm-hmm.
set will be there and the Cartesian product will be formed.
Okay.
All are related to themselves.
Are all are related to it. So very good, Asif. So what does that mean? We have selected a value. So what result we need? We need A comma A belongs to R. Here they have not given the ordered pair. Okay, they have given A or B, but sorry, belongs to R. So we can, but we still can write in this way. Okay, so this means what? A comma B, A comma A belongs to the relation R. We can also write like this, A R A. So that means A is related to A. So this is your choice. You can represent your answer in any way. But at the end, what we need this one. This is the same thing. So we need this A comma A belongs to R. So who can tell me Fahad? Fahad, what is mean by this? A is related to A. This condition is given. Can you apply this condition or this result and tell us that what is mean by this? A or A? A is related to A. A or A. Okay, for this is correct. Okay, ARA means A, check here. They are saying this second value is divisible by A. So what is mean by this? ARA, this means A is divisible by A. Let A belongs to natural number. We can say every number is divisible by itself. Every number is divisible is divisible by itself. You know that every number is divisible by itself. You have a 2 is divisible by 2, 3 is divisible by 3. So the same thing which we have written over here, that every number is divisible by itself. Okay, so that means A is divisible by A. A is divisible by A. This implies A is related with A. Hence, given relation is, hence, given relation is reflexive. Okay. So please do the practice. Then you will get used to of these types of questions. So in reflexive, what we need to do, we will assume a value. We will check, we will put this condition. If this will satisfy this, then we will say that this is reflexive. And if it is false, then we will just give a simple example. There is no need to prove it. Okay. So all of you, please raise your hand if this is clear. Okay, Zed.
Or if we have noted it.
Okay, Asif. Good. Okay. Okay, Ananya, good. Abdur, Mariam, this is clear. Okay, Mariam, good. Abdur, this is clear. Very, very good. Fahd. Abdur. Okay, very good. So all of you, please note down this. I will give you just 1 minute for this one. Okay, please note down this, and then we will start the next part, that is symmetric. Okay, I will just give you 1 minute for this. Please note down this one, then we will start the symmetric. Okay, now everyone, please tell me on the chat box. Before starting the question, we should know that what will result we need. So before starting the symmetric, we should know that this is symmetric or not. Then only we can start. So everyone, please reply me on the chat box that this relation is symmetric or not. Zed, very good. This is correct. Rifat, please again check your answer. Good, Abdur. Good, Ananya. Very good. Good, Fahd. Very good, Rifat. Now it is correct. Asif, Mariam, what is the answer? You can reply me on the chat box. Okay, please check here. Symmetric. Okay, what they are saying, B is divisible by A. They are, okay, Asif, we will check this. B is divisible by A. So for example, if we will take 4, then 4 is divisible by 2. Okay, 4 is divisible by 2. What is symmetric? Okay, but before that, we should know the definition. What is symmetric? If AB exists, then BA should also exist.
BA should also exist.
Okay, then we will say that it is symmetric. Now 4 is divisible by 2, but the converse of this is 2. 2 is divisible by 4 or not? No. 2 is not divisible by 4. That's why this is not symmetric. Okay, so this is not symmetric. So we will just give a simple example for this one. Okay, so we will write like this. Now the B is divisible by A, so the greater number should be here and smaller should be here. Okay, we will write like this: 2 comma 4, 2 comma 4 belongs to R. Okay, what this means? 4 is divisible by 2. 4 is divisible by 2, but 2 is not divisible by 4. But 2 is not divisible by 4. Okay, this implies this one 4 comma 2 does not belongs to the relation R. Okay, hence 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 the given relation is not symmetric, is not symmetric. Okay, hope this is clear to everyone. So please note down this. I will give you 1 minute for this one. And okay, Fahad, very good. Then raise your hand once it is done. Then we will start the transitive. Okay, Abdurrahman, Asif. Okay, Rifat. Okay, Fahad, Zaid. Okay. Okay, Mariam, very good. So I hope everyone has done this. Okay, then we will start the transitive. If anyone is left, then please let me know. Transitive. Now, for transitive, first we need to analyze this, that this is correct or not. So if we will check this one, the example which we have taken in the previous case. Okay. Just give me a minute. Okay. The example which we have taken in previous case, that 4 is divisible by 2. Okay. 4 is divisible by 2. So we are saying that, okay, Zad, we will check. 2 comma 4 belongs to R. Okay. 4 is divisible by 2. Now suppose if we will take another value, for example, 12. Now this 12 is divisible by 4. This also belongs to R. Now these two are common. So we get 2 comma 12. Please tell me this is correct or not. 12 is divisible by 2. Z, yes, now you are correct. Now please tell me 12 is divisible by 2 or not. Yes, 12 is divisible by 2. So please check here. If you're dividing the 4 with 2, if 4 is divisible by 2, then that means if you will do the factorization of 4, then you must get 2. If 12 is divisible by 4, if you will factorize this 12, you must get a 4. Now inside this 4 you already have 2, then definitely this 12 will get divisible by 2. Okay, if 4 is divisible by 2, 12 is divisible by 4, then 12 will also be divisible by 2. Okay, so first you need to analyze it. So yes, this is true. That's why we can't give any example for this. So we will prove this in a general way. So in transitive, what we will do, when we need to prove it is true, then we will take 3 values. Let A, comma B, comma C belongs to the relation. So if we will check the previous relation is natural number. So we will assume this is a standard. This first line is standard. Okay. You will always assume in case of transitive 3 values such that this is also a standard line, such that you will take 2 values and form an ordered pair, and you will say that this belongs to relation R, and take next 2 values B comma C in the same sequence, and we will say that this belongs to the relation R. So these two are fixed. Please note it carefully and learn it. These 2 lines are fixed. If we need to prove that this is transitive, always we will do like this one. If the set is not different, I will tell you that case later on. So we will do in this way. Now, what is mean by this one? AB belongs to the relation R. So this means B is divisible by A. B is divisible by A. And C is divisible by B. Yes, we need AC at the end. Okay, then we must know that what we have to prove. Okay, Fahad. So we will write in the rough that what exactly we need in the end. Okay, then we will prove this one. So what we need in the end AB belongs to the relation R, BC belongs to the relation R. So in the end, we need AC belongs to the relation R. So what is mean by this one? C is divisible by A. So you must know the result. Then only you can represent your answer. So at the end, we need this, that C is divisible by A. Now here, B is divisible by A, C is divisible by B. Then this implies C is divisible by A, C is divisible by A. This implies A comma C belongs to the relation R. Now we will write the same definition again, the definition of transitive. Thus A comma B belongs to the relation R, and B comma C belongs to the relation R. This implies A comma C also belongs to the relation R. Hence, given relation is transitive. So in every question, we will repeat the same step. The first and second line will be same. Then we will put this relation. Okay, but we must know that what the answer we need in the end. As per our answer, we will prove it. Okay, this is clear to everyone. Please note down this and raise your hands. Then we will start the next question. Okay. Okay, Zed, very good. Okay, Abdur, good. Okay, Fahad, good. Okay, so I hope everyone has done this. Okay. Ananya and Fahad, this is done. Shall we start next?
So 1 minute.
Okay, thank you. Okay, Umair, okay, Fahad, very good.
Done, sir.
Okay, Ananya, very good. Okay, so we have done this. Now we will try the second question. Second is a very simple question. Okay, we will check the second question. Okay, please try second. In some questions, even you can write language only. Okay, so try for second. On the chat box, first of all, please tell me that this is reflexive or not, the second part. Good. Abdul. Good, Zad, this is correct. Good. Okay, Asif, we will check. Okay. So, Mir, I hope you have written this question. Okay. Yes, that's correct, Umair. Okay, so I'm going to erase this. Now we will try the second one. Second part. We will first check for reflexive. Okay. What is the question? L1 is perpendicular to L2, where L1 and L2 are straight lines in a plane. So what they have done, they have not given us the set. For example, in the previous question, they have given the set as natural number. Here, they have, in place of set, they have written the language that what is L1 and L2? They are the straight lines in a plane. So what we will do, we will first of all assume a set. Okay, so it will become easy for us to represent our answer. Every time we can't write this statement that L1 and L2 are straight line in a plane. So we will assume a set. For example, let A be the set. Like normally set is given, but here in place of set, they have given this statement. So we will take this as a set. Let A be the set. A be the set of all straight lines, set of all straight lines in a plane. So what we have done in place of a statement, we have assumed a set so that it will become easy for us to represent our answer. Okay, now this set we have taken. Now the thing is L1 is perpendicular to L2. So if we will take a same line, suppose we have this straight line, let this be L1, then a line can't be perpendicular to itself. Okay, if you will take the same line on this, then these two can't be perpendicular. So we can just write a statement that a line can't be perpendicular to itself. A line can't be perpendicular to itself. Okay, hence the given relation is not reflexive. Okay, we need to prove that this is not. So we can just write a simple statement and we can say that this is not reflexive. Okay, so this was a very simple part. So I hope everyone understood this. Please raise your hand if this is clear. Then we will start the symmetric. Okay, Zad, good. Okay, Asif, very good. Okay, Ananya. All the other students, Abdur, good. Fahad, Mariam. Okay, Rifat. Fahad, I will reply you. Just give me a minute. Okay, so this is clear to everyone. If there was a horizontal line, then it, please check here, Fahad. This is line, suppose L1. If this is line L1, then where the other L1 line lie? The same one. So we have only this line. For reflexive, what we will do, we will take the same line. So if this is L1, then second line L1 is also this. Then these two are not perpendicular. Yes, Omer, you can draw the example. Okay, you can draw the diagram as example, but please write the statement also. Okay. Okay, Fahad, this is clear. Okay. So this is done. Next, we will start with symmetric. Okay. We will do the same thing which we have done in the previous question. We know that this is symmetric. Okay. If we have these two lines, so before starting of the question, you need to analyze it and need to check that this is symmetric or not. Then we will start proofing the question. We have these two lines, L1 and L2. If L1 is perpendicular to L2, then L2 is also perpendicular to L1. Okay, if L1 is perpendicular to L2, then L2 is also perpendicular to L1. So that means this is symmetric. Yes, sir, this is correct. Okay, now we will prove our question. So what we always do, we will assume two values from the set. So let L1 comma L2 belongs to your set. What is the set? Set is A. In the question, they have given a statement in place of set. That's why we have assumed this. Otherwise, each and every time we need to write the complete statement. So we have taken A as the set of all straight lines in plane. We have assumed L1 comma L2 belongs to A such that this is a standard. First and second line is standard. In every question, we will write these two lines such that L1 comma L2 belongs to the relation S. In this question, they have given the relation as S, not R. Okay, so L1 comma L2 belongs to the relation S. What does this mean? This means L1 is perpendicular to L2. L1 is perpendicular to L2. It's perpendicular to L2. Okay. Now in rough, please check that what you need to prove. What you need to prove? That L2 comma L1 belongs to R. We need this one. Sorry, not R, S. We need this one. What is mean by this? L2 is perpendicular to L1. So please check here. L1 is perpendicular to L2. Then this means, this implies L2 is perpendicular to L1. This is the same thing. Is perpendicular to L1. This implies L2 comma L1 belongs to the relation R. Sorry, not R, S. Belongs to the relation S. Now we will write the same thing again. L1 comma L2 belongs to the relation S. This implies L2 comma L1 belongs to the relation S. Hence, relation S is symmetric. Hence, relation S is, just give me a minute. Hence, relation S is symmetric. Okay. So I hope this is clear to everyone. Okay. Okay. So please note down this and okay, Fahad. So please note down this, raise your hand. If this is clear, then we will start. Okay, sir, very good. And we will check for transitive. Okay, sir, very good. So whoever has completed this, raise your hand and reply me on the chat box that this is transitive or not. Okay, because we will approach a question from your result only. Okay, Abdur, good. Very good, Umir. That's great. Okay, good, Rifat. Good, Asif. Ananya, Fahad, Mariam. Okay, Ananya, good. Okay, Fahad. So, Mariam, this is done. Good, Abdur, this is correct. Ananya, you have completed this. Shall we start next? Okay,
Yes, sir,
Mariam.
completed.
Okay, great. Now, next one. Next is transitive. Okay, so for transitive, first of all, we will analyze our result. Transitive. Now, for transitive, please check here. Suppose we have a line L1. This is perpendicular to L2. This is L1. This is L2. L1 is perpendicular to L2 and L2 is perpendicular to another line L3. Let this be L3. L1 perpendicular to L2, L2 is perpendicular to L3, then L1 and L3 will not be perpendicular. Okay, L1 and L3 will be parallel. They will not be perpendicular. So how we will do this? Again, the same thing. First and second step will be the same. So this is not transitive. Good, Zed. Let L1, we need three lines. L1, L2, L3 belongs to set A. What is a set of straight lines? Such that we will assume 2. Okay, because in this case, we can't put the value. That's why we are doing like this, such that L1, comma L2 belongs to your relation S and L2, comma L3 belongs to your relation S. This means L1 is perpendicular, okay, or we can choose a sign. Just L1 is perpendicular to L2 and L2 is perpendicular to L3. Okay, so here we have written L1 is perpendicular to L2 and L2 is perpendicular to L3. But from this figure, we understood that L1 is not perpendicular to L3. So we will write this implies L1 is not perpendicular to L3. This implies L1 comma L3 does not belongs to the relation S. Hence, the given relation S is not transitive. Is not transitive. Okay. So everyone, please note down this and raise your hand. If this is clear and you have completed this, then we will start the next question. So, okay, Abdur and Asif, I think you have completed this.
No, sir, this is for the last one.
For the last one? Okay, then please lower your hand. Okay. Okay, Abdur. Very good. Okay, Rifat. Good. All of you, please raise your hand if this is done. Okay, Zed. Okay, Asif. Okay, Fahad. Ananya and Umair, please confirm so that we can start the next question.
Done, sir.
Okay, good. Umair, this is done. Shall we start next?
Yes, sir.
Okay, very good. Next one. Now, next question. This is a very good question. Let a relation on the set R. Okay, set is given, which is R. Be defined as this. Show that R1 is reflexive, okay, and symmetric, but not transitive. Okay, you need to show that this is reflexive, symmetric, but not transitive. So please try to solve this question and share your answer. Okay, we will do one by one. So in the question, it is given that this is reflexive. So again, the same step. Please do this. And same step for symmetric, then check for transitive. Reflexive, very good. Okay, so I will do this again. Answer 2, reflexive. We need to prove that this is reflexive. So we will do them the same way. So what is the first step? You need to assume a value. So we will assume a value, let A belongs to the set. What the set is given? R, set of real numbers. So we will assume let A belongs to R. Now in the rough, you need to decide first that what result you require. What we need, this is your relation R1. What we need A comma A belongs to R1. This is reflexive, so we need this one, A comma A belongs to R1. What is mean by this? This means apply this condition that 1 plus A square is greater than 0. So we need this condition, 1 plus A square is greater than 0. If this is correct, then we will write this step. Now let A belongs to R. Now 1 plus A square, A into A. Suppose A is negative, then A into A will be Ananya. If A is negative, then A into A will be
Positive.
positive. Now in that positive part, if you are adding 1, then definitely you will get a greater than 0. If you will select any value from the real number, suppose if you select a positive value, then definitely it will be greater than 0. Now suppose if you select a 0, then what will happen? this will become 0, but there is 1. That's why this will give you a greater than 0. So we can write like this, that 1 plus a dot a should be greater than 0. This means what? 1 plus a square will be greater than 0. This means what? That a comma a belongs to the relation R1. Here the relation is R1. Hence the given relation R1 is reflexive. Hence the given relation R1 is reflexive. Okay. So I hope this is clear to everyone. If this is clear, then please note down this and try to solve the symmetric. I will give you 2-3 minutes for this symmetric. Okay, please try to solve this on your own. So you must know that what result you required. As per that result, try to represent your answer. Okay, please do this. Okay, so I think everyone has completed this. Okay, now I will solve this question, and please match your answer with this one. So for symmetric, who will tell me? Rifat. Rifat, please let me know what is the first step here. Let. Rifat, first of all, we will assume, okay, so in symmetric, what we do, we will always assume A comma B belongs to the set, that A comma B belongs to the set R. From the real number, we have assumed this. Okay, what is the next step? Rifat, can you check in the previous question what we have taken the next step? Rifat, your voice is not audible. No, Rifat, I can't hear you. Then who can tell me? Zed. Okay. Zed, will you please tell me what the next step is? Zed, are you there? Okay, who's Ananya, can you tell me what's the next step?
We have to substitute and find.
Okay, so in symmetric, first of all, we will assume this and we will assume this also, this line also, such that A comma B belongs to your relation. Okay, Abdul, very good, Abdul, this is correct. Belongs to your relation R1. Okay, so in symmetric, if you need to prove this is symmetric, we will always assume first and second line. We have assumed this one. Then what is mean by A comma B belongs to R1? This means this condition. 1 plus AB is greater than 0. Okay, so first and second line is the standard line. You always need to write these two. Then you need to put the condition which is given in the question. Now the next question is for Asif. Asif, will you please tell me that what we need to prove in this second part? Asif, your voice is not audible. Can you tell me what we need to prove here? No, no, Asif, I can't hear you.
In this,
Yes, Asif.
we have to prove that is it symmetric or not. That means that the first set is repeated inversely again or not.
Okay, so we need to just give me a minute, okay? Just give. Okay, sorry. So what is symmetric? If AB belongs to the relation R1, then we need to prove BA should also belongs to R1. Okay. So for symmetric, we need to prove if AB is there, then BA should also be there. If BA is there, then what the result we required? Who can tell me? Fahad? If BA belongs to R1, then what the result we required? Please put this condition. Please put this condition in this BA belongs to R1. Please analyze this. What is this condition? You will write the first value here. You will write the second value here. So if we will put this condition on this BA, then Fahad, can you tell me what result we will get? Yes, that is correct. If AB is minus, so B should be, yes, that is correct. Okay, so what condition we will get from here? 1 plus BA should be greater than 0. Okay, if AB belongs to R1, then you will get this 1 plus AB is greater than 0. If BA belongs to R1, then you will get 1 plus BA should be greater than 0. Okay, so we need this condition 1 plus BA should be greater than 0. Then how we will get this? 1 plus AB is greater than 0, then if you will interchange their places, then it will not affect the equation. This is also correct. And you can write this also that AB, A, comma B, sorry. If 1 plus BA greater than 0, then this implies B, comma A belongs to R1. Okay. So if B is there, then we can say this is symmetric. So we will again repeat the same thing. We will write in this way. A comma B belongs to R1. This implies B comma A belongs to R1. Hence, relation R, hence relation R1 is symmetric. Is symmetric. Okay. So this is a way of representing your answer. So in this chapter, please do a lot of practice. I will not give you so much homework, but whatever we are doing in the class, please do that at your home so that you will able to understand that how you need to represent your answer. Okay. So everyone, please note down this and raise your hand. If this is clear and you have completed this, then we will start the transitive. Okay, Asif, very good. Okay, Zad, very good. Okay, Rifat. Okay, Fahad. Okay, Abdul. Ananya, Umair, Mariam. Ananya, Umair, and Mariam. Please, okay, Mariam, very good. Ananya and Umair,
Answer.
very good. Umair, I hope you have completed this. Okay, we're starting the next question, next part, third one. Third is transitive. Third part is transitive. Okay. Now in the question, it is given that this is not transitive. So we will give an example. So how we need to select an example, please check here. We have this relation 1 plus AB is greater than 0. Suppose if we will take 1, okay. If suppose we will take a half here. Just give me a minute. Okay. So if we will take a half here, then this will satisfy this equation. Yes. 1 plus 1 into half will be greater than 0. This is correct. If you will solve it, you will get a 3 by 2. Next, again, if you will take 1 by 2, okay, we need to take an example for which this is not transitive. So if you will take 1 by 2 comma even minus 2, then will that satisfy your equation? No. 1 plus half into minus 2, this will give you 1 minus 1, which is 0. 0 is not greater than 0. So this example is not correct. What we will do, we will take a 1 by 4 here. So you need to analyze in this way. Okay. So we will take 1 by 4 here. So what will happen? Now everything will be fine. Please check here. 1 comma 1 by 4 belongs to the relation R1. 1 by 4 comma minus 2 also belongs to the relation R1. Please check here. This is 1 plus 1 by 4 into 1 is greater than 0 because this will give you 5 by 4 greater than 0. This is correct. Now this one. This we will check 1 plus 1 by 4 into minus 2. So this will give you what? 1 minus 1 by 2. So this will give you what? 1 by 2 greater than 0. So this is also correct. 1 comma 1 by 4, 1 by 4 comma minus 2. This is correct. Now these two are same. Now please check this 1 comma minus 2. So 1 plus 1 into minus 2. This will give you 1 minus 2, which will give you minus 1, which is not greater than 0. Hence, the given relation, hence the given relation is not transitive. Is not transitive. Okay, understood this? How you need to solve this question? They are saying that this should not be a transitive. So you need to take an example. You need to take two values which will satisfy the relation, and the third will not satisfy this relation. Okay. So please note down this and then raise your hand if this is clear to you and you have completed this. Then we will start the next question. Okay, Zaid, very good. Okay, Rifat, very good. Okay, Asif, good. Okay, Mariam. How we got 1 minus 2? Abdul, please check here. What is the transitive? For transitive, like we can tell, yes. Fahad, you can take any number in which first and second value will satisfy the relation, but third will not. if we will Abdul analyze the transitive, then what is transitive? A comma B comma C should belongs to the relation, but these two should also be common. Then A comma C should belongs to the relation R. If it belongs to the relation R, then you will say, yes, it is transitive. But if it will not satisfy the relation, then you will say that this is not transitive. So Abdur, how we are getting 1 and -2, please check here. These two are same. So remove the common part. So rest what you will get 1, and from here you will get a -2. This is clear, Abdur? Sorry, Abdur, your voice is not on. Okay, Abdur, understood. Good. Okay, so I hope everyone has completed this. Okay, so we are starting the next question. If anyone has left, please let me know. Okay, this we have already completed yesterday, these questions. Okay. Now, this question came in CBSE 2019. So this is a very good question. And this question is also there in your NCERT. Okay. So please try this question. First is they're saying it is reflexive. So you all know how to prove that this is reflexive. Okay, and I think there is something is missing. Please write this as A is less than equal to. Okay, this is the actual question. There is a misprint in this. A is less than equal to B. Okay, now please try this question for reflexive. The same step, first you need to assume, then prove, then write the ordered pair. Please try this one. Okay, Zed, very good. Good, Zed. Then Zed, please start the second part also, symmetric. Okay, now I will start for reflexive. Please check here. Reflexive. Okay, so the same step. Who can tell me? Rifat, can you tell me what we need to assume? Late? Okay, who can else tell me? Ananya, can you tell me what we need to assume?
Let
Late?
A belong to R.
A belongs to the on R. Very good. Here the set is also R. Very good. Let A belongs to R. Now you need to check this one. Okay. First you have assumed this, then check this condition. A is less than equal to A. So Ananya, this is true or false?
It's true. It's equal to A.
This is true. A is equal to A. Okay. So this sign means less than or equal to anything. So this is equal to A. So this is correct. So this means very good, Abdur. Abdur, this should not be symmetric. R is a yes. Whose question is this? Fahd. Yes, Fahd. In this case, we have the R also, or is the real number, and they have denoted the relation with R also. So we in the bracket we will write the real number. Okay, real number. Now A is less than equal to A. So this implies A comma A belongs to the relation R. Hence, given relation, hence relation R is reflexive. Relation R is reflexive. So hope this is clear to everyone. Okay, Zad, your answer is correct. Very good. Okay, so for the second one, please note down this and start the second. Now in the second, they are saying that this is not symmetric. So we will just take an example for which this is not symmetric. So everyone, please note down this and reply me on the chat box. Give me an example for which this relation is not symmetric. Okay, give me an example. Everyone, please. No, Asif, now the relation is different. Relation is A is less than equal to B. This is the relation. Okay, Umair, very good. This is correct. Next is Abdur. 2 is me. Abdur, you have taken 2 and -1. Okay, so that means -1 is less than equal to 2, but 2 is not less than equal to -1. Very good, Abdur. This is correct. Okay, so all of you, this is a very, very simple question. Symmetric. So first of all, we need to check that what is symmetric. AB should belongs to R, but BA should not, sorry, AB should belongs to R and BA should also belongs to R. But here we need to prove that this is not symmetric. So AB should belongs to R and the reverse of that should not be true. So this is a very, very straightforward question. Please check here for the symmetric. A is less than equal to B. So you need to select the first value, which is less than equal to the second value. So we will take example of Umair, which Umair has given. He has taken a very simple example. 1 comma 2 belongs to R. Very good. Okay. So this means 1 is less than equal to 2. But if you will check, then 2 is not less than equal to 1. This 2 is not less than equal to 1. So this implies 2 comma 1 does not belongs to the relation R. Hence relation R is not symmetric. Okay, is not symmetric. Okay, so if you need to prove that this is not symmetric, not reflexive, not transitive, then just give an example. So I hope this is clear to everyone. Please note down this, raise your hands if it is clear to you and you have noted down this. Then we will start next question. Okay, Fahad, very good. So Rifat, I guess you have some internet connection issue. Please check
Yes,
yours. Okay,
my
Rifat.
Wi-Fi got disconnected, so I joined by mobile.
Okay, Rifat. Please check here. So for symmetric, Rifat, we need to show that this is not symmetric. So we have taken this example. 1 comma 2 belongs to the relation R, but 2 comma 1 does not belongs to the relation R. Why? Please check here. 1 comma 2 belongs to the relation R means 1 is less than equal to 2. But 2 is not less than equal to 1. So that means 2 comma 1 does not belongs to the relation R. This is clear, Rifat?
Yes.
Very good. So all of you, please raise your hands. Once it is done, then we will start the transitive. Okay, so who has raised his hand? Okay, Asif. Okay, we will do a transitive. Then after that, we will take a 5-minute break and then we will continue our class. Okay.
Thank you, sir.
Okay, you're welcome. But please wait. First, we need to complete transitive. Okay. So everyone, please raise your hand once it is done. Okay, Rifat. Okay, Zed. Okay, Abdur. Ananya, Fahad, Mariam, Umair, please confirm if it is done. Okay, Mariam. Good. Okay, Ananya. Okay, Fahad. Umair, this is done. Shall we start next? Umair, I'm going to erase this. Okay, this is your example. So that means you have already done this one. Okay. Now third part is transitive. Okay. Third is transitive. So we need to prove that this is transitive. So again, the standard statement, first and second step is fixed. Now who can tell me? Okay, Mariam, can you tell me that what we need to assume in this one? Anyone can tell me what we need to assume here? The same steps which we are doing in every question. Let what we need to assume? Let yes, A, B, C. Let A, comma B, comma C belongs to the real number, the set. This is not relation. We have taken this as a real number. Real number. Okay. Such that A, comma B belongs to the relation R and B, comma C belongs to the relation R. So these two steps are fixed. So please learn these two steps. That in transitive, we will always take these two steps. In symmetric, we will always take a step A, comma B. Okay. In reflexive, we will take a step A. Now, such that A, comma B belongs to R and B, comma C belongs to R. So what does this mean? If A, comma B belongs to R, then apply this condition. This is again less than equal to, okay. So that means A is less than equal to B. Let this be first. And this means B is less than equal to C. Let this be second. Now please check here. 1 is less than equal to 2. 2 is less than equal to 8. Can we say that 1 is less than equal to 8? Yes.
So,
1 is less than 2, 2 is less than 8. Then obviously this one will be less than equal to 8. So from 1 and 2, from 1 and 2, what we will get? We can say that A is less than equal to C. So what is mean by this? This implies A, comma C belongs to the relation R. Now we will again write the same statement, okay, because we need to define it. So what we will write this, A, comma B belongs to R, B, comma C belongs to R. This implies A, comma C belongs to relation R. Hence relation R is transitive. Okay. So please learn the steps first and second. First and second are standard steps. So please learn this for transitive. Okay. Now everyone please note down this and then raise your hand. Then I will give you the break of 5 minutes. Okay. And in these 5 minutes, please do not use your phone. Okay. Please have some water, take a walk. Please do not use your phone. Okay. Otherwise your mind will again saturate. Okay, Zed. Zed, please wait for 1 or 2 minutes. Okay, Asif, good. Okay, Rifat, very good. Okay, Abdur, Ananya, good. Fahad and Umair, please confirm if this is done. Okay, Fahad, very good. Umair, please confirm. So, okay, then we will take a break of 5 minutes. Okay. Then we will continue our class.
so
Uh, Hello, all of you. I hope everyone is back. Please raise your hand if you're back so that we can, okay, Zed, so that we can start the next question. Okay, Fahad. All of you, please raise your hands if you're back. This question we will do later on, or please note down this question and do this in homework, okay? This is not a tough question, okay? Please do this one in homework. Okay, everyone, please raise your hand if you're back, okay? Zaid and Fahad, I know you're online right now. Rest of the students, please raise your hands. Okay, Zaid. Okay, Ananya, Asif, Abdur, Umair, Rifat. Shall we start? Okay, Rifat, good. So Rifat, please note down this question. Okay, and this is you need to do in homework. If you face any issue, then we will discuss in the next class. Okay, Asif, good. Ananya, Abdur, Umair. Ananya, Abdur, and Umair, please confirm if you are back. Rifat and Asif, please note down this question. Okay.
Yes, sir.
Okay. Everyone, please reply me if you're back so that we can start a class. Okay, Zat, Abdur, Umair. We can use any number to assume in this question. Fahad, again, the same approach. If you need to prove that this is false, yes, you can use a number. But if you need to prove that this is true, then you can't assume any number. Okay, you have to do in the same way as we have done the previous question. Okay, only in the false cases you can take an example. Okay, so I hope everyone has noted down this question. So please try to solve this. And if you will have any doubt, then we will discuss this in the next class. Okay, then we have this question where they are saying neither reflexive nor symmetric nor transitive. Okay, so in this question, you need to assume, you need to give the examples. Okay, so please start this question. Give me an example first for reflexive. First, give an example for reflexive for which this is not correct. And Abdur and Umair, I'm still waiting for your reply. If you're back, then please let me know. So we have almost 40 minutes. We will try to solve as much as questions possible. Now, anyone can give me an example for which this is not reflexive? Reflexive is very simple. Reflexive, that means you need to take the same value which will not satisfy this relation. For reflexive, you need to take a value which will not satisfy. It is reflexive, no, Fahad. Please check the question. It is written here, neither reflexive nor symmetric nor transitive. Okay, so think about a number which will not be satisfied by this equation. Okay, but please take an example for which this is false. Very, very good, Zed. This is correct. Okay, Abdul. Okay, so Abdul, please try this question. Then before this, we have check a question which you have to do in homework. Now, please, first of all, give me an example for this question for which this is not reflexive. Good, Umair, your answer is also correct. Zad, your answer is also correct. So I got 2 answers. Please try, everyone. Try to find an answer. Asif, Ananya, Abdur, Fahad, Rifat, please try to find an answer.
Yes, sir.
Okay, please check here. What is the relation? A is less than equal to B squared. Okay, A is less than equal to B squared. So we need to make this as a false. So what we need to do, we need to select 2 values. Okay, now normally if we will do a square of any number, then that number will become greater. If we will take any number B and we will do the square of that, then definitely it will be great. It will become greater than its previous value. But in what cases the square become less than the previous value, than the original value? When you will assume the value as like this. For example, if I will take the example of Umair, then Umair has given this example that take the values 1/2 and 1/2. For not some for not symmetric minuses. Okay, Zad, I will check this. Okay, so Zad has given this example that take 1/2 and 1/2. Because of a fraction, if you will do a square, if the value is less than 1 and you will do the square of that, then that value will become lesser than its original value. So if you will take this one, then 1/2 is not less than equal to 1/2 square. So that means 1/2 comma 1/2 is not related to the relation R. Hence, it is not reflexive. Hence, it is not reflexive. So in this case, you need to take a value which is less than 1. Similarly, Umair has given an example of 1/4. So he has also taken a value which is less than 1. Okay, so you need to think in this way that what value you will select so that when you will do the square of that, that become even less than the original value. So that value is less than 1. So you can assume any value which is less than 1. Okay. Okay, Zaz. So your answer is for not symmetric. Minus is less than square of 3. So you have taken this as 3 minus 6. That is correct. And then you have reversed it. So minus 6. But Zad, in both the cases, it is satisfying the equation. You need to prove that this is not symmetric. So, but before that, I will discuss this question. Okay, please try to find any other example. Okay, so everyone, please raise your hand if this is clear. Ananya, Asif, Abdur, Fahad, Rifat, please raise your hand if this is clear so that we can start the next. Okay, Abdul, very good. Yes, there is both the sign. Okay, then what is mean by this? Less than or equal to. Okay, so you can take any value which is either less than or equal to. -1 is okay. Z, then what you are doing? Then 3. Yes, Z, this is correct. Very good. This example is correct. Okay. For not symmetry, we can take. Okay, Umair, I will check. Okay, so I hope this is clear to everyone. Okay, now we will start with the symmetric. So for symmetric, I got 2 answers from Zad and Umar. All of you, please try for symmetric. Please try to check the value which satisfy the first part but do not satisfy the second one. Okay, that means A comma B will belongs to the relation R, but B comma A should not belongs to the relation R. Okay, so Zed, first of all, you have given the answer. So let me check this. You're saying -1 is less than 3 square. This is correct. Now you're saying 3 is not less than -1 square. Very good. Zed, this is correct. This is that answer. Good. Now, Umair, I need to check your answer. For non-symmetry, we can take 1 by 4 is less than equal to 2 square. Good, this is correct. Now you're saying, but 2 is not less than equal to 1 by 4 square. Very good, Umair. This is also correct. Okay, so I got 2 values, one from Umair and one from Zed. This answer is perfect. Now, Abdur, Rifat, will you please tell me the any other value which you found? Okay, Umair, good. So Ananya, Abdur, Fahad, Rifat, any other number? Okay, you can take the same example. If we will take the solution of Z and we will try to change the values, please check here. Take -1. Okay, so I got a message from Abdur. So -6 is less than equal to 5 square. That is correct. But 5 is not less than equal to, no, this, no, Abdur, please check here. It is satisfying this one. 5 is less than -6 square. Okay, so you can take the same example here. You can take the same value. -1 is less than equal to 4 square, but 4 is not less than equal to -1 square. Okay, so it's your wish. You can take any of the examples. So I will write here. First value which we have got is this. -1 comma 3 belongs to R, but 3 comma -1 do not belongs to R. Okay, you can show this. -1 is less than equal to 3 square, but 3 less is not less than equal to -1 square. Similarly, you can take this example also. Okay, 1 by 4 and 2. So this symmetrical part is done. Please check now for transitive. Fahad, I will check your answer. Just give me a minute. Okay, so Fahad, we can take 4 less than -2. 4, no, Fahad. minus 2 square is 4. So it satisfies the equation. Equation is 4 is less than equal to minus 2 square. This is correct. Okay, okay. So you are saying minus 2, but minus 2 is less than equal to 4 square. This is also correct. Okay, for both are correct. So this is not the correct example. We need to take example which will not satisfy this. Okay. Okay, so symmetric is done. Anyone will try for transitive? Please try for transitive. Okay, otherwise let me check this transitive. So if you will take 2 and minus 3, yes. Then if you will take minus 3 and 1, minus 3 is less than equal to 1. This is also correct. But 2 is not less than 1. This is also correct. Okay, first this, or we can take a second example. 2 minus 4, this is correct. Minus 4, 1, this is correct. And 2 is very good. So we have a multiple of example in this case. For example, if you will check this, please check here. This belongs to the relation R, this belongs to the relation R. Please check this. 2 is less than equal to minus 3 square. This is correct. Minus 3 is less than equal to 1 square. This is also correct. But 2 is not less than equal to 1 square. So that means 2 comma 1 do not belongs to the relation R. You can take this example, you can take this, you can make infinite example from this. Okay. So please check this case. 2 minus 3 belongs to the relation R, minus 3 comma 1 belongs to the relation R. Okay, but if you will remove the common part, then 2 comma 1 does not belongs to the relation R, hence it is not transitive. Hence it is not transitive. It is not transitive. Okay. So I hope this is clear to everyone. You can take the second example also. And in homework, you can try multiple of examples for this. So please raise your hand if this is clear to all of you. Okay, Zed, very good. Okay, Ananya, good. Abdur, Fahad, Umair, Rifat, this is clear. Abdur, Fahad, okay, Abdur, good. Fahad, Umair, okay, Rifat, good. Fahad and Umair, this is done. Shall we start next? Okay, I hope this is Fahad, this is clear. 3 square will be 9. Okay, Fahad. Okay, so 2 is less than equal to minus 3 square, which is 9. Similarly, minus 3, can I leave for, okay, sir. Okay, sir, then we will wait, okay? Okay, you're welcome. Okay, then I hope everyone has done this. We will start next one. Okay, this we have already done. Parallel to line L2, this question is we have already done, okay? Okay, so now we will do the questions which are based on equivalence relation. Okay, so this we have done. We will not do this. So please note down just the heading, questions based on equivalence relation. Please note down the heading and then we will start the next question. This question number 1, this we have already completed. So there's no need to do this again. Okay, we have done a perpendicular. Okay, so do this in homework. This is a very simple question. I'm sorry, we have done a perpendicular one. So please note down this and do this in homework. You need to show that this is an equivalence relation. That means this should be reflexive, transitive, and symmetric. So please note down this and raise your hand if this is done. Then we will start next question. Everyone, please raise your hand if this is done. Then we will start the next question. Ananya, Abdur, Fahad, Umair, and Rifat. This is done. Shall we start next? No reply. We have still 30 more minutes. Not 30, 25. Okay, Ananya, Rifat. Okay, because we need to complete our syllabus. So we will take equivalence means all should be same. Yes, for that means reflexive, symmetric, and transitive. Okay. So Abdur, this is done. Abdur, okay. Okay, Fahad, good. Umair, please confirm if this is done. Umair, I hope you have completed this.
Yeah,
Yes.
it's done.
Do I need to change the slide, Umair? Umair, your voice is not audible, but if you have not noted down this, then please do it right now. Okay, good. This is also homework. This is a very simple question. Okay. This is, please do this in homework. So I have given you 3 questions. We will discuss these questions in the next class if you have any doubt in this. Okay. So please note down this and then raise your hand. These are very, very simple questions. That's why you need to do this in homework. Please raise your hands once you noted down this, then we will start next question. Okay, Ananya, very good. Abdur, Fahad, Umair, Rifat, please confirm if you have noted down this. Okay, Fahad, good. Abdur, Umair, and Rifat. Okay, Rifat, Abdur, and Umair. Abdur and Umair. Okay. Abdur, this is done. Shall we start next? Abdur, yes or no? Abdur, I guess you have completed this. Okay. I'm going to start next, Abdur. But if you have any doubt, then please let
Can
me
you show the
previous
question?
previous one.
Yes, sir.
Okay. Please note down this one. Okay. So this is a very simple question. Is congruent to? So you know that what is meant by congruent. We have done in the previous classes. Okay, Abdul. Good. Umair, I hope you have done. You have noted down this.
Yes, sir. Yes.
Okay. Good. This question is also very simple. It is similar to. Okay. You know that what is similar. So please note down this. Do this question in homework. Whose question is this? Fahad. Okay. What is meant by okay. So please check here. What is the difference between the congruent and similar? Congruent means exactly same. Exactly same. So that means what if you have a triangle? It is congruent to other triangle. Okay. It's congruent to other triangle. Or we will take a simple example. We have these two hands. If you will say that these two are congruent, then if I will place my second hand back of the first one, then you can't see the second one. Similarly, from this side also, you can't see my second hand. So that's why I will say that these two are congruent. Congruent means exactly same. Exactly same. There will not be any difference. Okay, so these two hands are congruent. So if you will put this triangle 1 on 2, there's a rough sketch. But if you will put this 1 on 2 or 2 on 1, then you can't see the second triangle because they are exactly same. Then we will say it is congruent. Now, what is meant by similar? Similar is what? Whose shape are same. Okay. For example, if this is a small triangle and this is a bigger one triangle, then these two are similar, but we have some properties to check that these are similar or not. Hope you remember the property. If you have the side ABC, this is DEF. Okay. Either these angles are equal or the sides are in proportion. In that case, we will say that this is similar. Okay, this is an NCERT question, but this is a very, very simple question. You can do this one. For example, if I will tell you about the reflexive, then every triangle is similar to itself. So it is reflexive. What about symmetric? T1 is similar to T2, then T2 is also similar to T1. What about third one? Transitive, T1, T2, T3. Okay, so please try to solve this question on your own. This is a very simple question. You can do this. And if you will face any doubt, then we will discuss this in the next class. But I'm confident that you can solve it. Okay, what is the next question? Yes, this is a good question. This we will do in the
Sir,
class.
can you show the previous question, please?
Yes, yes, yes. So everyone, please note down this question. Okay, and confirm me and then raise your hand. Then we will start the next question. Okay, Ananya. Thank you. Abdul, Fahad, Umair, Rifat, please raise your hand if you have noted down this question. Okay, Abdul, good. Okay, Fahad, good. Umair and Rifat, this is done. Okay, Rifat, good. Umair, I hope you have done this.
I'm writing this second.
Okay, okay.
So,
Okay, very good. Next, yes, this is a very, very good question. Please note down this question. Try to prove that this is equivalence relation means reflexive, symmetric, and transitive. So please try to prove that this is reflexive. Okay, then I will help you for this one. Please note down this. Try for reflexive. Okay, same step. You need to select a single value. The integer is z here. Okay. Okay, I hope everyone has done this. Please check here. Reflexive. Okay, so first of all, same step, let assume a value from the set. What is the set here? Set is integer z. Integer is given. So we will assume let x belongs to integer. This is the first. Next, please check here. What we need for reflexive, we need x comma x. What is mean by x comma x? X minus x is divisible by n. We need this one. We need this statement. So what is x minus x? 0. Anyone can tell me 0 is divisible by n or not? Anyone can tell me 0 is divisible by n or not?
No.
Yes, yes, yes. 0 is divisible by every number. Okay. So now we will go in this direction only. So let x belongs to z. X minus x is equal to 0 is divisible by n, is divisible by n. This implies x comma x belongs to the relation R. Hence the relation R is what I will reply you in 1 minute. Hence the relation R is reflexive. Okay, so I hope this is clear to everyone. Okay, in in positive integer 0 also no further, it will not come. Okay, but what in this question it is saying? It is saying that n is a positive integer, but z is what? Z is all the integers. Okay, z is not a positive integer. In z, we will include all the negative positive numbers. Okay, for okay, okay. Only n is a positive integer, not z. So we have proved this. This is reflexive. Okay. Now we will prove that this is symmetric. Okay. Now who will tell me? Omer. Omer, please tell me for the symmetric one, first what we need to assume.
So we need to assume if x minus y implies y minus x.
Yes, but what is the first step? You always need to assume the value x comma y belongs to the set
Belongs
with
to z.
z, such that
Such that x minus y.
x comma y belongs to
Yeah, I mean x comma y belongs to R and
very,
belongs to
very
R and y comma x belongs to R.
yes. So first and second line is fixed. We will always do like this. This implies such that x comma y belongs to R. This implies what? X comma y, sorry, x minus y is divisible by n. Is divisible by n. Okay. We have said here that x comma y belongs to R. So that means x minus y is divisible by n. What does this mean? This means we can write this like this: x minus y is equal to, we can say anything. For example, n, we can use the symbol lambda, and we can say lambda belongs to z. Okay, what is mean by this one? Please check here. Suppose we have 18. 18 is divisible by 3 or not? Anyone?
Yes, sir.
Yes, 18 is divisible by 3. That's why we can write this 18 as 3 into any number. So in this case, it will be 6. Suppose 50. 50 is divisible by 4? No. 50 is divisible by 2? Yes. So we can write this 50 as 2 into some number. Suppose we have 100. 100 is divisible by 4. So we can write this 100 as 4 into some number. So if a number is divisible by any other number, then we can write it as n into. Suppose this is divisible by n. That's why we can write this as x minus y is equal to n into any number. In this case, that number will be integer. Okay, there must be some integer which we will put here. But if this is divisible by n, then we can represent this as n lambda. This is clear. Ananya, Abdur, Fahad, Amir, and Rifat. This is clear.
Clear, sir.
Okay, good. Okay, Fahad, good. Abdur, Umair, Rifat. Okay, Umair, good. Abdur. Okay, Rifat, this clear. Rifat, this is last question. Okay, then your class is over. So please just focus for 5 or 10 minutes. Rifat, this is clear. Hmm, I guess. Okay. Now we have assumed that x comma y belongs to R. What we need y comma x belongs to R. Okay, you should know that what you need. Y comma x belongs to R. That means you need y minus x is equal to, should be divisible by n. Okay, now x minus y is equal to n lambda. Then y minus x will be what? We will multiply this with negative, so we get a minus n lambda. If x minus y is equal to n lambda, then y minus x will be what? Minus n lambda. Just multiply this equation with minus 1. This implies y minus x is divisible by is divisible by minus n. Sorry, is divisible by n. This implies y comma x belongs to the relation R. So we'll repeat that x, thus x comma y belongs to R. This implies y comma x belongs to R. Hence relation R is symmetric. Okay. So I hope this is clear to everyone. So please note down this and raise your hand if this is done. Then we will start the last, that is transitive. So this is the last topic. So please focus just for 5 minutes. Example of y minus x. Yes, Fat. So for example, let me erase this one. Okay. For example, we have a 3. We are saying that 9 minus 6 is divisible by 3. That's correct. 9 minus 6 is divisible by 3 because 9 minus 6 is 3. If you will do the opposite of this, 6 minus 9, we will get what? Minus 3. So minus 3 is also divisible by 3. You will get a minus 1 if you will cancel out this. Okay, Fag? Okay. So everyone, please raise your hand. I know you are tired now. Just focus for 5 minutes. Okay. In 5 minutes, we will complete the transitive. Everyone, please raise your hands. Lambda, okay. Abdur, for example, okay, Ananya, okay, Rifat. Abdur, for example, if I'm saying to you that we have a 30, I'm saying to you that 30 is divisible by 3. So you can write this 30 as 3 into some integer. Similarly, if I will say to you that 64 is divisible by 4. So you can write this 64 as 4 into some integer. Okay. Similarly, if I'm saying to you that this x minus y is divisible by n, then you can write this x minus y as n into some integer. So that's why I've put this lambda. What is lambda? It is an integer. Clear, Abdur? Abdur, this clear? Okay, very good. So I hope everyone has done this. Now we will start the next part. Next is transitive. Okay. The last part. Okay. Okay. Umer, so in the last, just keep, okay. So in the last part, what we have said, we are saying that x minus y is divisible by n. Yes, Fahad, you are correct. Okay, if 30 is divisible by 3 and we are getting 10, that 10 is a lambda. You are correct now. Okay, so Umer, x minus y is divisible by n. That's why we have written this x minus y is equal to n lambda. Lambda can be any integer. For example, 68. This is divisible by 2. So you can write 2 into some integer. Okay, because this is divisible by 2. That's why you can write this like this, 2 into an integer. Similarly here, x minus y is equal to n lambda. Now, if you will interchange this, you will multiply this with negative, you will get here minus. Okay, Omir, this clear? Y minus is equal to minus n lambda, then how y minus, okay. Check here. Omir, 9 minus 6 is equal to 3. So this 3 is divisible by 3. Now 6 minus 9 is equal to minus 3. Minus 3 is also divisible by 3 because you will get minus 1 here. So minus 3 is divisible by minus 3 also. Minus 3 is divisible by n by 3 also. Okay, Umir?
Okay.
Okay. So this is the last part. Okay. So most of the students has dropped. Transitive. Okay, so what we do in transitive, we will assume three values. Let x comma y comma z belongs to z. Okay, x y z belongs to z, such that x comma y belongs to the relation R and y comma z. This small z is a number and capital Z is an integer. Okay, y comma z belongs to the relation R. So what this means, x minus y is divisible by n, and this y minus x is divisible by n. Sorry, y minus z is divisible by n. Okay, so x minus y is divisible by n means what? We can write this like this: x minus y is equal to n lambda. Lambda belongs to any integer. Similarly, this y minus z can be written as n into some other number. So what symbol we will use? You can use this new, where this new is belongs to any integer. Okay. Now let this be 1. We will repeat this question because most of the students has dropped. So in the next class, we will again repeat it. So add 1 and 2. If you will add 1 and 2, then please check here, y will get cancelled out and you will get x minus z, which is equal to n lambda plus n new. So from this, you can take n common. So you will get lambda plus new. Okay. So this, we can say this implies x minus z is divisible by n, because in the starting you have an n, so x minus z is divisible by n. So this implies x comma z belongs to the relation R. We will write the same statement thus x comma y belongs to the relation R, y comma z belongs to the relation R. This implies x comma z belongs to the relation R. Hence, it is transitive. Okay. So please, all of you note down this and then our class is over. I guess we need to reduce our timing because most of the students drop after 1.5 hour. Okay. So we will discuss in the next class. We will decrease our timing. Okay, Umair, what is your doubt? What will we get after adding? What we get, Umair, if we will add this, then y will cancel out and we get a x minus z. And on the right side, we get n lambda plus n nu. Okay, so everyone please note down this. And your homework is the 2-3 questions which I have given from the today's slide, as well as the assignment one. Okay, so please do the questions from this slide. Do the assignment one. In the next class, we will discuss your doubts and then we will continue this topic. Okay, and this is a tough chapter. That's why I need some time on this one. Okay, so if you have noted down this, then you can drop. Okay. Yes, for next class will be on Saturday. Okay. For yes, you can. Okay. Please join 30 minutes early so that we will complete the previous topic. Okay. Okay. Similarly for you, Ananya, please join 30 minutes early on Saturday so that we can complete the previous topic which you have missed. Okay, fine.
Thank you. Sir.
You're welcome. Okay.
Thank you, sir.
Okay, you're welcome. Okay, Umair, I will explain. Abdur, I'm not sure that from which question you have been dropped.
So from the transitive.
From the same question, this one?
Yes. Yes.
Okay, okay, okay. Then Abdur, please note down this. Okay. After that, I will explain to you. Okay. And Rifat, if you have completed this, then if you wish, you can drop off. Okay. On Saturday, please join at the same time. Once the relation and function will be completed, hopefully on Saturday, then from Sunday, please join 30 minutes early so that we can start the matrices. Okay, Rifat? Okay, Umair, please check this logic. Abdul, please check this question, okay, so that I can explain both of you. We need to prove this, that this is transitive. X minus y is divisible by n. Okay, we need to prove that this is transitive. Okay, so what we have done in transitive, we have assumed three values, x, y, and z, which belongs to the integer z. We said that x comma y belongs to the relation R and y comma z belongs to the relation R. Yes, Rifat, if you wish, you can drop off. Okay. Now, just give me a minute. Okay. So Abdur and Umair, please check here. So x comma y belongs to the relation R, y comma z belongs to the relation R. So that means x minus y is divisible by n. That's why we can write this as x minus y is equal to n lambda. Lambda can be any integer. We have already discussed why we are writing like this. Suppose we have a 10, 10 is divisible by 2, so we can write this as 2 into 5. Similarly, we have a suppose 15, this is divisible by 3, so we can write 3 into any integer. That's why x minus y is divisible by n. That's why we have written this n lambda. Okay. Now y minus z is divisible by n. That's why we have written this n nu, because we need a new symbol here. So we have used this. Nu belongs to z. Now add 1 and 2. Add 1 and 2. So what we will get, x minus z is equal to n lambda plus n nu. Now, if we will add these two, then Umair, please check y will get cancelled out.
So why do we add it?
Yes, Abdur, why we added this? Because we need x minus z. Okay, because we need to prove that x comma z belongs to the relation R. So belongs to the relation R means we need x minus z. So from these two equations, how we will get x minus z? We need to remove this y. How can you remove this y? You need to add both the equations. Okay, Abdul?
Yes, sir.
Okay, so when we add these two, then we get what? X minus z, which is equal to n lambda plus n nu. And you can take common. Now, if outside the bracket you have n, then you can divide this term with n and will get cancelled out. That's why we can say that x minus z is divisible by n. Okay, and if it is divisible by n, then this will be related to the belongs to the relation R. That's why we are saying that this is transitive. Okay, Omir, now is it clear?
Yes, sir.
Okay, very good. So please note down this, and once it is done, then if you wish, you can drop off. Okay.
Also, it's done. Thank you.
Okay, you're welcome. Okay, Abdul, so this is the homework assignment 1, and I have given some questions on homework. So please do that. We will discuss in the next class.
So the assignment one, the from this chapter.
Yeah, from this chapter. Please check on my portal because I've discussed with the management yesterday, and I hope they have uploaded the assignment. Okay.
Okay. So for these type of questions, you have to consider lambda and mu.
You can use any symbol. You can use P, you can use Q, but do not use any symbol which is already there in the question. Okay.
Okay, sir. Thank you, sir.
You're welcome.